Okay, welcome back. Today we're going to be looking at the vertical stretch of a trig graph, and we're also going to be looking at the horizontal stretch, which we call period change, because that's what's going to happen. It's going to change the period of our graph. All right, so first off, let's talk about vertical stretch of a graph. So vertical stretch is represented by A in front of whatever trig graph we're talking about. And we are only going to be manipulating the sine and cosine graphs, okay? So like I said in our last lesson, we need to know all of them, but sine and cosine are the only ones that we're actually going to be manipulating. So A represents a vertical stretch just like it has in every function you've ever dealt with. That number in front is a vertical stretch. If A is negative, then that means we're going to have a reflection over the horizontal axis, over the x-axis. So what we have here is three different cosine curves. And I want us to focus first on this one right here. This is our normal cosine curve. Okay, normal cosine curve. And we can see it keeps going because as we talked about, right, they repeat. We have a cosine wave. Then let's look at this one up here. Okay, let's look at this one. Actually, I'll do that one in purple. All right, this is another cosine curve, but it has been vertically stretched. Okay, think we can see that? So if you think about it, it has a stretch factor of 4, right? It's been stretched by a factor of 4. It goes from positive 4 down to negative 4. Then the last graph I put on here is this one right here. So this one looks like an upside down cosine curve because it has reflected. That A must be negative, okay? It's reflected over the horizontal axis and it has a stretch factor of 2, right? Instead of being at 1, it has not only reflected, but it has also stretched. So we're going from -2 to +2. There's a stretch factor of 2. So that's what we're doing with A. So let's look at our first one right here. We have y equals the cosine, or excuse me, y equals 2 cosine of theta. So on this first graph, I'm going to put my parent graph points, but then I want us to get to the point where we can do this kind of just mental math. We're just thinking about what's happening to the graph. So pi over 2, pi, 3 pi over 2, and 2 pi. And this is where I was saying you guys need to have these graphs memorized. Nothing wrong if you plot the parent graph each time, just, time consuming, and we want to be able to go straight to our main one if we can. All right, so we are only going to graph one period, which means for cosine, the period is 2 pi. So we're only going to graph this from 0 to 2 pi. Okay, so there is one complete cosine curve, but we want to stretch it by a factor of 2, which means instead of going from -1 to 1, if we stretch that by a factor of 2, it would go from -2 to 2. So we want to take all of our values and stretch them by a factor of 2. Well, if you stretch 0, it's still 0. Okay? Then -1 stretched would become -2. Again, 0 is still 0. And then +1 stretched by a factor of 2 becomes 2. So that instead of going from -1 to 1, we are going from -2 to 2. All right, now, ask some questions over here. Yesterday I said there's something called amplitude, and we were going to talk about that a lot more today. So here we go. Amplitude is the distance from the midline to our maximum value or our minimum value. Or another way of looking at it is it's half the distance between the minimum and the maximum. Well, the midline here is the middle of our graph vertically speaking. So our midline on this one is literally the x-axis. And then the amplitude is the distance from this midline to the maximum, which is 2, right? So the distance from the midline to the maximum is 2 units. Or it's also the distance from the midline to the minimum, which is -2, which is also 2 units. So the amplitude is 2. And you could also say, oh, well, that's the same thing as that number out there. And yes, that is true, but it is the absolute value because a negative represents that reflection and amplitude is a measurement of distance, so it's always positive. All right, the period for our graph is 2 pi. That's how long our interval for one complete curve. The domain, all reals. Okay, even though we're only graphing one period, it is technically all reals. The range is what has changed here. The range goes from -2 to 2, where normally a cosine goes from -1 to 1. Okay, let's look at our next one. Y equals -3 sine of x. All right, so again, pi over 2, pi, 3 pi over 2, and 2 pi. We'll start doing some with degrees here soon as also. We've done all radians so far, but we could also do any of these in degrees. All right, so on this one, normal sine curve, okay? And then when I get to my next one, I'm not going to plot my parents anymore, okay? Here's my normal sine curve, one period of it. I'm going to stretch it by a factor of 3, but also I'm reflecting it over the horizontal axis. So here's what that means to me when I'm thinking about this visually. Rather than starting and going up, it's going to start by going down. Okay, plus we're stretching this by a factor of 3. So we're going to have -3, and then up here we've got +3. So I'm still going to start at 0, 0, but I'm going to go down. That's the negative reflection by a factor of 3. So my next point is at pi over 2, -3. Then my sine curve, we start to come back up with my wave. At pi will still be 0. And then at 3 pi over 2, it's going to be a +3. We're stretching it by that factor of 3. And then we will come back down to 2 pi. Okay. And there we have the sine curve that we're talking about. And I'm going to go ahead and erase this one. Now, if you plot the parent graph points, okay, you don't have to erase them, but you need to make sure it's clear what your final graph is. Maybe you just do the points, or maybe you just do it very lightly with a pencil. Okay, so here is one period of our new graph. And the amplitude on this, so our midline, well, that's our middle, vertically speaking. That's right here. Some people like to draw their midline first because sine always starts at the midline. Okay, if you want to do that, by all means. Amplitude is the distance from the midline to the max or the min. That's 3. Again, it's always positive. The period, even though I erased my 2 here, the period is 2 pi. Domain is all reals. The range on this one, -3 to 3, because we stretched by a factor of 3.